Okay, so now we are ready to move on to derivatives with the product or quotient rule and the chain rule. So in the previous batch of videos, went through a bunch of problems where we did derivatives using the chain rule. Now it's going to get mixed in with a product or quotient rule, and the difficulty and the amount of algebra in these problems goes up exponentially. It's a lot more work. Um, Please, take your time, be careful, try not to be frustrated. It's easier said than done. So consider here the product f of x equals x cubed square root 4x plus 2. X cubed square root 4x plus 2. Okay, before we even find the derivative here, obviously I can't distribute through here. That's an issue. What about the domain of this thing? Remember, this involves a radical, so an even square root for that matter. So it's not going to be defined for negative numbers. So if 4x plus 2 is negative, then the radical won't be defined, the whole function won't be defined. So 4x plus 2 has to be greater than or equal to 0. If you solve that inequality, you would get x greater than or equal to negative 1/2. All the only x values we're allowed to put in are values that are greater than or equal to negative 1/2. So that's the main right here. We want to just find the derivative though. So first things first, I'd like to kind of get this out of the way. I know at some point I'm going to have to do the derivative of that square root of 4x plus 2, or alternatively the quantity 4x plus 2 to the 1/2. Right? Right now I have x cubed next to it, so I'm going to have to use a product rule. But at some point I'm going to come to where I need that derivative. So rather than wait till I need it and then have to come back and work it out, I'm going to be proactive and get it out of the way first. So we recognize the inside part as 4x plus 2. The outside part would be u to the 1/2. And then we go ahead and we use our chain rule. So it'll be the derivative of the outer function, the u, which would be 1/2 u to the minus 1/2. Then times the derivative of the inside function. You might notice here I'm writing a little bit less detail out than usual than I've done in some of the previous problems with product and quotient rule or with the chain rule. So I'm writing a little more detail out. If you need to write some more detail out, please still go ahead and do so. Here we can simplify. 4 times 1/2 is 2. And instead of u there, I want what u is, which is 4x plus 2. Now, if that was going to be my answer to the problem and I was done, then I would write this without negative exponents. But I'm going to be using that a little bit later in the problem. So I'm going to keep it with negative exponents for now. Keep it with negative exponents for now. And so now we return to our problem. F of x is equal to x cubed times the square root of 4x plus 2. So by the product rule, f prime is going to be x cubed times the derivative of the other function, 4x plus 2 to the 1/2, plus the 4x plus 2 to the 1/2 times the derivative of x cubed. And here I'm writing out that extra detail. And I'd encourage you early on to do that, to really kind of tie together how everything works out. Now we know derivative of 4x plus 2 to the 1/2. That's the thing we just worked out here in the box. And of course we know how to do derivative of x cubed because that's just a power. So we can go ahead and work those pieces out. That'll be x cubed times the stuff we have there. So that will be 2x cubed, 4x plus 1, or 4x plus 2 to the negative 1/2, plus, and then derivative of x cubed is 3x squared. I'm going to put that in front, and then 4x plus 2 to the 1/2. Now, pretty much guaranteed that this is going to happen when you do the chain rule alongside the product or quotient rule. And that is, you're going to have a common factor, some quantity. Now, we also have x's that can be pulled out. We have an x squared and an x cubed. But that really doesn't matter because we're factoring not for the sake of factoring, but factoring rather as a way to simplify. Factoring as a way to simplify. So here we have 4x plus 2 to the minus 1/2, 4x plus 2 to the 1/2. So we're going to factor that out of our problem. Now when we take that out, for the first part, when we take 4x plus 2 to the minus 1/2 divided by that stuff, they're just going to cancel out. And so we'll have 2x cubed. When you get to the second fraction, if we take that 4x plus 2 to the positive 1/2 divided by 4x plus 2 to the negative 1/2, we'd have to use our properties of exponents, which say we subtract. 1/2 minus the negative 1/2 becomes 1/2 plus 1/2 becomes 1. So that's actually going to be plus 3x squared times 4x plus 2 to the first power. And then we just need to go in and simplify this a little bit more. All right, we just need to multiply out, combine any like terms. And then that's all going to be over 4x plus 2 to the minus 1/2 because the negative exponent's going to make it go to the bottom. So I did a little bit of cleaning up there. 3x squared times 4x plus 2 will be 12x cubed plus 6x squared. And then, of course, we're still adding on the little 2x cubed. And so put those together, we'll get 2x cubed plus 12x cubed is 14x cubed plus 6x squared. And when I moved the 4x plus 2 down to the bottom, instead of writing that stuff to the 1/2, I went ahead and transformed that into a square root. If you wrote it as quantity 4x plus 2 to the 1/2 power, that's perfectly fine as well. So now we've done our first example here using the product rule, in this case, with the chain rule. And you can see it is a bit of algebra that we have to deal with. And that's just something we got to face up to.